Hello students, welcome back to chemistry class. In the previous class, we have started a new chapter, that is metals and the non-metals. Okay, and today we will continue with the physical properties of metals and the non-metals. Okay, the physical properties of metals and non-metals. Now, okay, so the physical properties, mainly what are the physical properties? Let us discuss the first physical property, that is the physical state of a metals and non-metals. The physical state of a metals and non-metals. When we talk about the physical state, so what property it exhibits? When you look at compound or what condition it is, whether it is solid or it is liquid or it is gas. Okay, let us differentiate the physical state of metals and non-metals. Okay, for that let us make a table. In the first table, first column you write metals and the second column write non-metals. Non-metals. Okay, the first column let us write metals, the second column let us write the non-metals. Let us go to differentiate the metals and the non-metals. What is the physical state of the metals? Okay, when you talk about the metals like iron, the metals like copper, the metals like aluminium, when you talk about what state it is, they are all in solid state. Okay, the metals like, here I am writing the symbols. Iron can be write Fe, iron, copper, the symbol of copper it is Cu, zinc it is Zn. Okay, aluminium, it is aluminium. These all are metals and which is in a solid state. Solid state. So usually these metals, like most of the metals are in the solid state. But I have used the term usually. There are some exceptions. Okay, there are some exceptions. What is the exceptional case? So children, when we talk about the metals, there are some exceptions. Here you can see a mercury, a metal, mercury. When you talk about mercury, the symbol is Hg. Hg. Okay, is it a solid state? No. So mercury will be in a liquid state at room temperature. Not only mercury, a gallium. Gallium. The symbol is capital G and small letter A. The gallium also an exceptional case, which is also present in a liquid at room temperature. Okay. And when we talk about non-metals, what are the non-metals? Can you say some examples? Most of the gases like hydrogen, like oxygen, like nitrogen, etc. are in a which state? Yes, they are in a gaseous state. Gaseous state. So children, usually I can say that most of the non-metals are usually in a gaseous form or in a solid form. Usually, here also I am using the term usually. Usually the non-metals are either in the form of gas or in the form of solid. But children, here also there are some exception. What is the exception? Any non-metal is there in the liquid form? Yes. Here you can see a bromine. The symbol of bromine it is Br. Capital B and small letter R. Bromine. A bromine exists in the room temperature at a liquid form. Okay. So how can you differentiate this? Generally, you can differentiate the physical state of metals and non-metals such a way that most of the metals are hard. They are in a solid state except mercury and gallium. Even the cesium also. The cesium also can be exhibited in a liquid state at room temperature. And when we talk about non-metals, most of the non-metals are gaseous state or solid state. Even if there are also some exceptional case. Here the exceptional case is the bromine. Bromine exhibit the which state? Bromine is present in the liquid state. Okay. So the first physical property when we talk about, most of the metals are hard and most of the non-metals are soft. Soft means they are either in the form of gas or in the form of liquid. Sorry, or in the form of solid. Okay. Compared to the metals, non-metals are soft. Okay. Now let us go to the second physical property. The second physical property, that is the second physical properties of metals and non-metals. Let us differentiate. Secondly, we can discuss lustrous. Lustrous or metallic luster. What is lustrous? Lustrous means shine. Lustrous means shine. Here also, let us differentiate the lustrous in the case of metals and non-metals. The case of metals and non-metals. Okay. Okay, students. In the case of metals, when you talk about gold, simple only I am writing gold, silver, it is Ag. Okay, platinum, it is Pt. Okay, if you take these metals, you can see these kind of metals are shine. They have a shine surface. Okay, and when we talk about the non-metals such as sulfur or iodine or bromine, you can say that they never shine, they do not shine. But the metals like gold, silver, platinum, etc., they are shining. That is why they are used to make a jewelry purpose. Okay, to our jewelries, the chain, the necklace, such kind of jewelries are made up of using these metals because it shows a lustrous capacity. The lustrous ability is there. Okay, still you can see the metals like sodium, the potassium, lithium, etc. They are not that much shine. So generally we cannot say that all the metals are shine. These are compared to these metals, these three metals are not that much lustrous. But when you cut these metals, you can see inside there is a portion which is lustrous. Okay. But generally you can say that most of the metals are lustrous and most of the non-metals are non-lustrous. And here also there is an exception. What is the exception? The exception is that graphite. So children, what is graphite? Graphite is one of the allotrope of carbon. Graphite is nothing but carbon itself. Since it is a non-metal, it shines. It has a capacity to shine. Okay. And this is the second property, the metallic luster. Okay. Now we will move to the third property. The third physical property of metal, it is the third physical property we are going to discuss here is the malleability. Malleability. So what is malleability? Malleability is the ability of a metal to be turned into thin sheets. Okay. Malleability is defined as the capacity or capacity of metals to be turned into thin sheets. Be turned into thin differentiate the metals as well as non-metals. Metals as well as non-metals. Okay. So malleability. Okay. Children, you might be familiar that the covering of the sweets, the common sweets like rasgulla and all. Here you can see a silver coating. Okay, a silver sheet which is there on the top of the sweet. Or you can see aluminium foil paper, which we are mainly used to cover up the food items, especially the sweets, biryani and all. That silver paper, that aluminium foil paper. Okay. Okay. In the case of metals, you can generally say that most of the metals are malleable because which can be beaten once you beaten with the hammer or whatever materials. Okay, whatever items are there, once you hammer it, you can say that which will be beaten into thin sheets. Thin sheets. So you can say that most of the metals are malleable. And what are non-metals? The non-metals like chalk piece, the non-metals like, okay, so whatever non-metals like chalk piece or the duster or the plastic, okay, plastic, chalk piece, etc. are non-metals. Is it malleable? No. Because if you hammer it, you can see that it's broken into two different pieces. Okay, so non-metals are non-malleable, and the metals are malleable. Okay, and there we have other physical properties also. The next class we will discuss ductility, the melting point, boiling point, and the conduction of heat and electricity. Today let us find up the session with the 3 physical properties. Okay.